Okay, let's start by reading the problem description for squares of a sorted array. Given an integer array nums sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. Example 1, we can see that after squaring, the array becomes 16, 1, 0, 9, 100. After sorting, it becomes 0, 1, 9, 16, 100. Example 2, we can see that after squaring and sorting, it becomes 4, 9, 9, 49, 121. For the constraints, we can see that the length of the array will be greater than or equal to 1, less than or equal to 10 to the fourth. The values will be greater than or equal to negative 10 to the fourth, and less than or equal to 10 to the fourth. And nums is sorted in non-decreasing order. And we have a follow-up question. Squaring each element and sorting the new array is very trivial. Could you find an O of n solution using a different approach? Which we can and we will. For our approach, we're going to utilize 2 pointers in a single for loop. This solution has a big O of n time and space complexity. The general idea is we'll compare the squared values of the numbers the pointers are currently on, and whichever squared value is greater, we'll place it in the result output array from right to left. We'll start by initializing a variable called result with an empty array, and we'll set up our 2 pointers. One that will start at the beginning of the array, and the other at the end of the array. Next, we'll set up a for loop that will iterate backwards. The first thing we'll do inside of the for loop is square the values of both pointers. Our first if condition will check if the pointers are equal. If they are, then that means they're both at the same index, and it doesn't matter which squared number we place in the array because it's the same number. Our next if condition will check if the left num squared is greater than the right num squared. If it is, we'll place the left num squared in the results array at the furthest available index at the end and increment the left pointer. Else, if the right num squared is greater than the left num squared, we'll place the right num squared in the results array at the furthest available index at the end and decrement the right pointer. Finally, we have an else block that will catch ties. When there's a tie, it doesn't matter which number we place into the results array. In this case, I just went with the left num squared and we increment the left pointer. Once the for loop exits, we return the result array. Here we have example 2 from Leetcode. Our pointers give us a left num squared of 49 and a right num squared of 121. The pointers are not equal, so the first if condition evaluates to false. The left num squared is not greater than the right num squared, so our second if condition evaluates to false. The right num squared is greater than the left num squared, so our else if condition evaluates to true, and we add the right num squared to the fourth index in the result array, and we decrement the right pointer. The loop iterates, and now we have a left num squared of 49 and a right num squared of 9. The first if condition evaluates to false. Left num squared is greater than right num squared, so we add left num squared to the third index in the result array and increment the left pointer. The loop iterates, and now we have a left num squared of 9 and a right num squared of 9. Our first 3 conditions evaluate to false since we have a tie, and our last else statement triggers. So we add the left num squared to the second index in the result array and increment the left pointer. The loop iterates, and we have a left num squared of 4 and a right num squared of 9. 9 is greater than 4, so our else if condition triggers, and we add right num squared to the first index of the result array and decrement the right pointer. The loop iterates, and both of our pointers are on the second index, which has a value of 2, giving us a left num squared and right num squared of 4. Our first if condition triggers, and we add 4 to the 0 index of the result array. The for loop finishes, and we return the result array. Let's translate this to code. Okay, we'll start by initializing a variable called result with an empty array. We'll initialize a variable called left pointer with the value of 0. We'll initialize a right pointer to start at the last index of our nums array. Then we'll set up our for loop. We'll initialize the index to start at the last index of our nums array because we need to increment backwards. We'll check that the index is greater than or equal to 0, and then we will decrement the index once the code block is finished executing. We'll store the left num in a variable called left num. We'll do the same for the right num. Then we'll square the left num and store it in a variable. We'll do the same for the right num. For our first if condition, we're going to check if the left pointer is equal to the right pointer. And if it is, we're at the same index, and it doesn't matter which number we store. So in this case, I'm just going to store the left num squared. our next if condition, we're going to check if the left num squared is greater than the right num squared. And if it is, we're going to add the left num squared to our current index of the result array. And then we are going to increment the left pointer by 1. Else, if the right num squared is greater than the left num squared, we're going to add the right num squared to our current index of the result array. And then we are going to decrement the right pointer. Else, we have a tie, and it doesn't matter which number we add. So in this case, again, I'm going to go with the left num squared, and then we're going to increment the left pointer by 1. And then finally, we return our result array. And that's it. That's our solution. Let's save it and run our test cases. And we get the expected output. Let's copy and paste this into Leetcode. Okay, let's paste it in here. Hit submit. And we get an accepted solution.